All right, today we're in section 9.4, real numbers. In our books on page 470. Okay, the first slide is basically just talking about the difference between a rational and an irrational number. A rational number is any whole number, obviously, and then any number that has a terminating or repeating decimal. An irrational number has a decimal that doesn't terminate, so it never ends, and it doesn't repeat either. It just has some random, it just has random numbers that just continue on forever. So I like how this chart lays it out. Basically, this side of the chart talks about rational numbers. That includes integers, like we said, whole numbers, and then also terminating decimals and repeating decimals. Irrational numbers are everything else. But they're both considered real numbers. All right, so now this chart basically just shows you some examples of that. So 5/8 translates to what decimal value? 0.625. Since that's a terminating decimal, I know that it's rational. Now 5/6 translates to 0.83 repeating. Since it's a repeating decimal, it's also rational. But notice the third one, the square root of 19, produces a decimal of 4.35889894, and it keeps going. There's no pattern to my decimal. It does not end, so I classify it as non-terminating, non-repeating, and it is irrational. Okay, do you see the difference between rational and irrational? All right, so what does that look like in question form? Okay, so you're going to see this on your quiz for sure on Monday. Being able to determine whether or not a number is rational or irrational. So I want you to change each one of these to its decimal version. Okay, so change it to its decimal form, and then tell me, is it rational or irrational, and why? Okay, so if it's irrational, tell me why, and if it's rational, tell me why. Okay, 2/3, when I convert it to a decimal, is what? 0.6 repeating. So rational or irrational? Rational. Why?
I have no idea.
Because it's repeating. What about square root of 100? 10. So it's rational because it's an integer. Or if you said whole number, that would be fine too. All right, what about square root of 6? Is it?
Irrational.
It's going to be 2.44948, and it keeps going. So it is irrational because it's non-terminating and non-repeating. All right, now what about the square root of 16 over 25?
0.8.
It's going to be 0.8 because it's going to be 4/5, which translates to 0.8. So it is rational, and why? Because it's terminating.
Yeah.
It's terminating. All right, anybody get all four of those right? All four right? Any questions? Any questions? All right, so this is very important part of the lesson, being able to determine whether a number is rational or irrational and being able to tell me why, not just a guess. 50-50, okay, let me see, irrational. No, that's not going to cut it, okay? You've got to be able to tell me why. All right, moving on now to example 2. In example 2, they want us to compare these real numbers. So the first thing we need to do is we need to compare them in the same format. So we're going to convert both of these to decimal form, and we're going to round to the nearest hundredth where necessary. So in our calculators, what is the square root of 2 rounded to the nearest hundredth? 1 41 hundredths. And what is 9/5 rounded to the nearest hundredth if necessary? It's going to be 1 8/10. Okay, so now that they're in the same form, I can clearly see that which one is bigger. Okay, 1.8. Now, this isn't my final answer. I need you to make sure that you write your final answer in the original format. So the square root of 2 is less than 9/5. And that would be your answer. Okay, just comparing these real numbers. All right, any questions? All right, I want you to do one. Compare the square root of 4 to 3/2. Okay, so convert them both to decimals, compare them, and then write your answer in the original form. All right, okay, so let's go over this. What is the square root of 4?
2.
Okay, 2, and this is a blank. Okay, what about 3/2? 1.5. So it's clear that which one's bigger? 2. So now just write your answer back in the original format. The square root of 4 is greater than 3/2. Okay? Yay. Did you get it?
I forgot to do it in form view, back to the form.
Okay, so just make sure you do that. Now on a quiz, there's just going to be a blank. Like this would be your work, converting it to a decimal. And then in the blank, you would put the greater than or less than sign. So you wouldn't have to worry about writing it back in the original form. Now, the same cannot be said for example 3. On example 3, you're going to have to remember, Wesley, you're going to have to remember to write them back in their original form. Okay, so you just got to remember that. All right, so let's look at example 3. It says use a number line to order these numbers from least to greatest. What do you think you have to do first?
Number line.
Well, yeah, but convert them all to decimals. Okay, so go ahead and write these 4 numbers as decimals. Okay. Okay, now probably the most difficult part of setting up a number line is going to be this. What numbers or what intervals do you increase the number line by? And you're going to determine that based on the range of the numbers that you are plotting. So what is the smallest value that I have here in this set of numbers? Negative 2.8. So I know that the first number to the far left of my number line has to be a what? It's got to be a negative 3. Okay, because I have to go a little bit past the smallest number. Now, what is the largest number? 1.73, so I know I have to at least go above that. So because of the large range of numbers, I need to just increase by intervals of 1. Okay? All right, now, it's not going to be exact, but I can go ahead and plot 1.3 just above the 1, and I need to make sure that I label it so it's clear. All right, which point belongs with which interval. All right, and then negative 2.8 comes down here. Negative 2.24, that's going to be pretty much right here. You might need to draw an arrow. That would be fine. And then 1.73, which would be up this way. All right, now this is your work. This is not your answer. Your answer is to order them from least to greatest. Well, you can clearly see from the number line that which one is the smallest? Negative 2.8. In its original format, how did they write it in the original? Negative 2.8. So that's going to be my first value. What about my next one?
Negative 2.2.
Which in its original format was what? Negative square root of 5. Okay, what about the next one? 4/3. And then the largest? Square root of 3. All right, and this is my answer. I used the number line to figure it out and to show my work, but that's going to be my answer. All right? You think you can do one?
No.
Yeah, of course you can.
I don't want to.
Of course you can. Okay, use the number line to order the numbers from least to greatest. Now remember, change them all to decimals first so you can figure out your range of numbers. And then plot them on the number line and then order them least to greatest. Alright, so first one's already a decimal. We'll just rewrite it. Alright, so 2 9/10. What's the square root of 10?
3.16.
3.16. Alright, what about 7/3?
2.33.
2.33. And what about 2 to the square root of 2?
2.83.
Okay. 2.83. Alright, so what is your smallest number? 2.33. What's your biggest? 3.16. That is a really close interval. If you write them by whole numbers, all of your points are going to be so clustered together that it's going to be really difficult to be accurate with it. Does that make sense? Like if I did 0, 1, 2, 3, all of my points would be right there, just so close together. So I need to spread out my intervals wider than that, or basically a narrower value. So I could go by tenths. I could go by, skip every 2/10. And I think that would probably be the best way to do it, is to go every 2/10. So my smallest, you said, is 2.33. So I'm going to start at 2. And then my next one, I'm going to say 2 2/10. And then my next one, 2 4/10. Do you see what I'm doing? I'm increasing by 2/10 every one. 2.6, 2.8, 3.0, 3.2, and you don't need this many. I just drew my number line too long. I'll go up to 3.4. Okay, and then we don't need the rest of these. Okay? All right, so now I set my intervals for my number line based on my values. Does that make sense? So now I've spread it out to the point where all my points aren't going to be so clustered together. And now I'm just going to graph them. Go ahead and finish plotting your points on the number line, and then order them least to greatest in their original format. All right, so 2.33, I'm going to plot right between 2.2 and 2.4. All right, and then yes, I need to go ahead and label it 2.33. All right, and then it goes 2.83. So kind of like right there. 2.83. And then, wow, that one's still pretty close, 2.9. All right, and then 3.16. So this one's about right there. And okay, that should be it. All right, so based on these numbers, which one is the smallest in its original form? Okay, 7/3. Where am I going to write my answer? All right, I'm going to write it right here. 7/3, then what? 2 square root of 2, then what? 2.9, then square root of 10. All right, and this is my answer. The number line is my work, and then putting them back in order in original format is my answer. Sorry it's all squished together. I kind of ran out of room. All right, if you understand that, that's all you need to know for 9.4.